Good morning, everybody. Again, everybody can hear me in the back okay? Maybe people could spread out a little further because, there are two people too close to me here. It gets claustrophobic. So I've been involved in password security for a long time. Maybe some of you have heard of Diceware. That was one of the things I did. I have a bunch of other things. I don't want to spend a lot of time on that. Diceware, the last time I spoke, it was available in 17 languages. Now we're up to 22 languages and growing, so there's a lot of support from the community. Obviously, I'm not doing these translations. I've also written a bunch of dummies books. According to the news magazines, Hillary Clinton learned about email from reading my book, so it's all my fault. One more book plug. I recently encountered this, and if you haven't seen it or haven't heard of it, and likely you haven't, these are a series of lectures that were given in the 70s by the head of the National Cryptologic School for the National Security Agency. And they're mostly declassified. There are a few little bits whitened out. And they're really fascinating. If you want to learn about computer security from the people who actually do it, who are talking frankly to their recruits, not talking to the general public, I highly recommend this. So much for advertising. Okay. Today's problem is how to deal with the storage of the answers to security questions. Now, I think there's almost unanimous opinion in the security community that security questions are a bad idea. And at the same time, they're ubiquitous. And there are good reasons for that, which is that people do forget their passwords. And not only do people forget their passwords, but sometimes in the course of upgrades and this and that's, through really no fault of their own, their password records get corrupted. And you can, if you've been through spending hours on the telephone with the help desk for these sorts of things, you know it's a pain. And one of the problems is how does the company that's providing the service know who you are? And for better or for worse, it seems that security questions seem to be an area that has been widely adopted and hasn't been readily replaced. My interest in this came from a bunch of discussions on Perry Metziger's cryptography list. NIST was proposing their new guidelines that they would allow people to remove spaces between words in a passphrase. And the question is, why would you even think of something like that? But anyway, it was a lot of pushing and shoving to get them to say, well, maybe we won't allow that. And it's an issue particularly for passphrases like Diceware, where you can run two words together and make a different word, a word that was already on the list, and thereby shorten the effective strength. Anyway, one of the things that came up was that somebody gave an example of security question answers where removing spaces and other forms of canonicalization is actually a helpful thing to do because it increases the likelihood that when the time comes to check an answer that a user submits, that it will match up because maybe a person put in a space, maybe didn't put in a space, or capitalized the letter, didn't capitalize the letter. You really don't care that much about that for the security answer check. But in the course of this, the question came up why that people, a lot of places, hash the answers. And the question was, why would you do that? Because when you hash an answer, even a small error can result in invalid hash. There's no such thing as close in a hash answer. And the answer was that legal departments and companies are very concerned about the fact that these security answers may contain personal information that they don't want to be responsible for storing. And that's an answer, but in fact, hashes aren't really going to do very much to protect you. And it seemed wrong, and I got interested in that, and I felt it was really important to document in some detail why that really is a bad idea. Now, security questions have a long history. I think we were all familiar with the "What's your mother's maiden name?" question, which I think goes back to George Washington's time or something. I actually got asked. I had to open a bank account just a couple of weeks ago, and they asked me that question. Like this is their idea of security. There are lots of problems with the whole security question business. The fact that you can, for example, there are all these genealogical sites, and even if you don't have your genealogy up there, your third cousin once removed has the family genealogy up there, and it's easy to figure out your mother's maiden name. You know, your second cousin twice removed's first name, all that kind of stuff is pretty readily available and getting more so. My talk is basically going to be focused on storage, how to safely store these answers, which is a kind of a narrow cut on this whole problem. But I think, again, it's important because the way people are doing it seems to me is wrong. But one interesting attack that isn't related to storage that I just read about a couple of weeks ago is a person-in-the-middle attack, if you will, where people are creating some attractive-sounding website offering a free account, and when you sign up, it starts to ask you security questions, but what it's really done is gone into your Gmail account or gone into your bank, and when they pose a security, to do a password reset, when they ask a security question, they reformat it as a security question for creating an account on this new dating site or whatever the heck it is, and as you type in the answers, they feed the answers back, and that way they can they can hopefully get you, from their perspective, hopefully get you to inadvertently reset your account on your bank or your what other thing is important. All right, it's back to storage. Basically, if you're going to have security questions, you have to store the answers. Okay, and since everybody agrees that security questions are a bad idea, there's very little advice on how to do this. You know, if you're going to do it anyway, what's the best way to do it? The latest version of the NIST SP 863B guidelines basically say don't do it. I'll discuss that more in a couple of slides down the road. OWASP has a page on this, which is actually pretty good. They have a lot of suggestions, but they basically say, you know, hash it or encrypt it. It's your choice. And obviously, you don't want to store plain text of these answers because that's the most dangerous thing you can do. But secure storage is not so simple. And we're all familiar with the endless stories of security breaches, everything from Ashley Madison to the government Office of Personnel Management, where apparently the Chinese intelligence agency now has a copy of everybody's security clearance forms from, I think, whenever the breach was, 2016 or 2015, all the way back to the 40s or whatever. This is a slide. I went to another presentation. There are two types of companies, according to, this is, at that time, FBI Director Mueller saying there are two types of companies, those that have been breached and those that will be. And one of the federal judges responded, there are only two types of companies left, those that have been hacked and those that don't know they've been hacked. So the whole question of, you know, protecting the information, the actual bits that are stored in the corporate database, it's not, obviously you want to make sure people can't copy that to the best of your ability, but you can't rely on that. It's just too many examples where that stuff's been stolen. So again, OWASP suggests doing either way, encrypting or hashing. For questions, some security question setups let the user create their own question. In that case, the questions themselves have to be recoverable. So those questions have to be encrypted. But the answers, at some level, you only really need to know whether an answer submitted later on matches the original answer. And at first blush, hashing seems to do the trick. So one issue of hashing is that it discourages complex answers. In other words, if you've wrote a little sentence or two about your first grade teacher, you're unlikely to type that same sentence again 6 months down the road when you've forgotten your password. On the other hand, lawyers like hashing because, again, from their perspective, out of sight, out of mind, we've hashed this data. We're no longer storing it. Nobody can claim we're misusing private information. And if there's a breach, they can claim, well, we did what everybody said you should do. You should hash it. And again, one of the purposes of this talk is to sort of try and document once and for all that really doesn't solve the problem, that isn't a good enough answer. So probably most people here, I take it, are familiar with what a cryptographic hash function is. I don't want to have to go into too great detail on it, but basically they're a one-way function. They scramble up the data. They take however much data you put in, reduce it to some fixed size in such a way that even a 1-bit change in the input should make a change on the average half the bits in the output. And there are many of these around. MD5 and SHA-1 are kind of old and people are discouraged from using it, but there's a whole bunch of newer ones that are still considered secure. And there's a big but, which is that even though you can't, given an output, it's not computationally easy or even feasible to undo the calculation that produced that output. On the other hand, that output acts as an oracle. It acts as a tool that can, if you have a guess as to what the input might have been, it will tell you whether you're right or wrong. It won't tell you anything else. It won't say you're close. It won't say you're warm, you're cold, but it will say if you're right. And the problem is that most of the standard hashes were designed to be computed efficiently. And that lets you test lots of guesses quickly. And nowadays, a lot of these algorithms can be run on graphics processing units, which have multiple computers in them. They're designed, obviously, to make computer gaming efficient, but they also turn out to be really great for trying to crack passwords. And for example, one of the newer model NVIDIA GPUs for $500 and change can do 2.8 billion hashes a second. So if you have a few million possibilities, it can rip through those in almost no time. So the model that people are using for storing security question answers is essentially the same model that people use for storing passwords themselves. And there are a couple of different levels for doing that. The simplest is just to hash it, and that turns out to be not a great solution because of the ability to pre-compute large quantities of hash outputs and store them and just do a table lookup to find them. The better approach is salting, where you add a random nonce, a random string of bits that you store with the user's password, and you incorporate that in the hash so that no two users will hash the same password the same way. And then there are more advanced hashes that have been developed, which deliberately try to slow down the process, either by doing the same hash over and over or by doing more complicated things where they use up lots of memory. These have a lot of advantages and are probably the best practice these days for storing passwords, but we'll talk about that in a minute, that these are not necessarily suitable for the security question answers. And then the final thing is a keyed hash, where you use a secret key that's corporate-wide when you form these hashes, and that's more secure, but you now have a single point of failure. If somebody breaks into the software and can get hold of that key, then they have access to all your secrets. Okay. And I think, as we all know, there's some more talk scheduled today, crackers are winning the arms race with password storage hashes. Cracking is a massively parallel process. You don't have any of the complexity where intercommunication slows down parallelism. You can just run a whole bunch of processors at the same time, and they one of them just has to raise their hand when they found the answer. Moore's law is working against you. The economics of gaming. Gaming is a very lucrative business for the computer industry, so a lot of technology has gone into massively parallel processors for gaming, and they're available very inexpensively. In addition, for Bitcoin and other cybercoin minings, people are developing special purpose chips, which again will let you go from billions of guesses a second to trillions of guesses a second. So what I'm going to show is the problem is even worse when it comes to security question answers. Again, enterprise databases are hard to secure. They need to be accessed by many different places. They have to be backed up. They often have to be synchronized in terms of multiple sites so that the volume of data that actually comprises the security answers is small enough that if a hacker can get into the system, they can pump that stuff out through various channels really in a matter of seconds. And again, even if they can only get a part of the file, that can often be enough. Very often, an attacker who wants to attack a corporation really is just looking for one account that they can get into and then escalate privileges on that account so that even if they get a chunk of that password answer file, that can be helpful. There are some advantages that the security question answer storage problem has over password storage. First of which is that whatever access to these security questions takes place is fairly rare. You do it when you first create an account. You do it if for some reason you need to change those questions, and you do it when you need to reset your password. And that for each user is typically going to be, at most a couple times a year, hopefully. In addition, the reset information, once you've cleared the hurdle of answering these security questions, is typically sent by email. So the fact that you have some security on your email account provides another layer of protection. But the bad news is that there are a lot of ways to get around email protection, intercepting, and a lot of it's not encrypted, so you can intercept it along the way and somehow get whatever little special code they send you. They sent the correct user, the attacker might be able to get hold of it. And in any case, this is a two-factor authentication system, if you will, the security question answers plus the access to the email. But if the security question answers are not securely stored, you're back to one factor. Okay, this is the new draft, the NIST, used to be the National Bureau of Standards, the federal government's primary group for producing standards for computer security. They are producing a new version of their 863 series of security recommendations. And one of their sections, they use the term knowledge-based verification. And they have two bits of guidelines, one of which is the cryptographic service provider, whatever CSP stands for, shall not use knowledge-based verification questions for which answers do not change regularly over a period of time. For example, what was your first car? And I think maybe they're thinking about a situation like where a bank or a credit card company can say, what was your last transaction, or what was the last thing you bought on the credit card? And that's actually reasonable advice, but for a lot of situations where password reset takes place, it's in a situation where the user really hasn't been on that site for months and months and months. So the reason they forgot their passwords is they're not using it regularly. So it really begs the question, which is that if you want to authenticate a user where you have nothing but what they answered, the bunch of questions, it really has to be information that's long-term from the user's perspective. Otherwise, they're not going to remember what meal they had, on November 12th last year. The other thing that I found a little weird is they can they allow the possibility of multiple choice answers of at least a minimum of 4 answers per question, and I have no idea what they're thinking there. If you present me with a security question challenge when I'm trying to break into account, and I have 4 questions, 4 possible answers, you know, it's a 25% chance I win. Even if I have 2 questions, it's, you know, 1 in 16. I can try 16 accounts till I break in. I mean, it's like, but maybe they're thinking of something I don't quite understand. Anyway, so I went to looking for some examples here. I went to a government website, Medicare, which obviously affects large numbers of people, they presented me with a series of security questions to try and establish an account, and I just to make them a little bit more legible from the back of the room. These are the questions they asked. What are your favorite vacation spot? In what city did you meet your spouse? What country would you most like to visit? What is the title of your favorite book? What is the name of the first street you lived on? What was the name of your first pet? And what is your best friend's last name? So already they're clearly not following the NIST guidelines, but again, right now they're just a draft anyway. We'll see when they come out of Medicare changes their practices, which I doubt. So going back, in each of these items, there's a question, and then there's a target space. What are the kinds of information they're looking for? So forgetting about first or last or favorite or least favorite or one you hate the most, they're talking about vacation spots, cities, countries, books, streets, pet names, and last names. And the point here is that if you're trying to figure out what the answer is, you don't really need to know what the question is. If you're trying to decode the answer, all you need to know is what answer space they are. So here's another site. There's a site called goodsecurityquestions.com, and this person, for $20, PayPal, you can get a list of 200 suggested security questions, of which he's done research on in terms of both evaluating how good they are as security questions, and also done some surveying from members of the public to see how much people like them. And you know, from my perspective, $20 for that kind of information seems like a fair price. So I don't want to, you know, spoil his thunder. This is just the sample questions he has on his web page. And again, his targets are first name, last name, wedding hall. What was your wedding hall when you got married? Your school and your city. And I also looked at his top 40 questions. Again, I don't want to give these away, but of them, first or middle name was accounted for 13 questions, last name 9 questions, city 5, and street 3. So there are lots of ways to come up with a question that produces one of these answers, but the space of answers is actually much more limited. Here's a third example. This was from last night. They had a reception. I, with permission, took this woman's a picture of her T-shirt, and again, these are hacker small talk questions. What was your childhood pet's name? What street did you grow up on? What was the make of your first car? Which is actually one of the ones that NIST specifically said don't do that. And your mother's maiden name, and is your voice your passport? The last one actually being one of the nice alternatives to security questions. Okay, so the question is, the sort of the meat of this talk is, you know, so how many answers are there, right? And I've tried to come up with some bounds on this. So in terms of the, you know, and again, I'm focusing here on the United States. A similar analysis would take place for different countries, and for the most part, you know, when you're attacking a website in a particular country, you know, you would use the names and the typical names and typical cities and so on in that country. So the United States population on July 4th this year was 323 million people, and that's a lot. So there's at most 323 million first and last names in the United States. If you look at that in terms of entropy, the way we measure strength, so basically you can think of entropy as of some random number as how many coin flips you'd have to make to get something that was as random as that number. So for 323 million, that's about 28 bits of entropy. In other words, picking one person out of the United States is equivalent to flipping a coin 28 or 29 times. And I also, on these charts, I've also tried to make it a little bit more intelligible, what would be an equivalent password. So when our little lowercase a refers to one letter out of the 26 possible letters, so this would be like a 6-character random password. But you can also look at the census data has an analysis of those last names, and there are only about 3.9 million last names in the United States as of 2010. If you look at that from the entropy viewpoint, it's only 22 bits, and that's more like a 4-letter password plus 1 digit. Now, if you look at, again, they've done this analysis, if you look at names that occur more than 50 times in the census, that accounts for 92.8% of the population. So you can get the vast majority of Americans with only 276,000 last names, and that's roughly equivalent to a 3-letter plus 1-digit password. Now, first names, I haven't found anybody that actually, the Census Bureau does not analyze first names. They do things like the most popular names and stuff like that. The best site I could find lists 5,000 common names in the United States, and that gets you down to like a 2-letter and a digit password. Places, again, there's a National Board of Geographic Names in the United States and the U.S. government that comes up with the official names for maps and stuff like that. They track 2.2 million names in the United States and 6 million names worldwide. So that would include streets, cities, beaches, all the sorts of things that a security question asks about a place. And again, if you're looking at cities, you're only looking at cities with at least 2,500 people, which accounts for 81% of the U.S. population. There's only 3,500 of those. So again, we're back down to the equivalent of a 2-letter plus a digit passwords. One of the security questions is, what country would you like to visit? There are 196 countries in the world, even if you count Taiwan, which, you can get the political questions about. And that's equivalent to a 1-letter plus 1-digit password. Roads, there are a lot more of those. Again, there's about 2.3 million of those. But if you look at states, if you know what state the person is in for some reason, that cuts it down again by more than a factor of 10. Pets, the ASPCA says there are about 163 million cats and dogs in the United States. Who knew? That's actually a pretty large number by our standards. But if you look at common pet names, again, there's a My Dog's Name and MyCatsName.com, and they seem to be different companies. But anyway, we're back down to thousands. Here's two cats I'm associated with. One has a low security name, Ruben. The other has a higher security name, Sucia. Unless you know Spanish, in which case it's not such high security. Okay. Other types of answers, colleges. Worldwide, there are about 40,000 institutes of higher education. There's about 131,000 K through 12 schools in the United States, counting public and private, 43,000 zip codes. There are 38 million books in the Library of Congress. That includes, I think, 470 languages. If you look at I found a best books ever lists, and there was only about 50,000 on that. Okay. Oops, wrong this. Okay, so basically, there are not enough possible answers. And the first chart here, I'm taking the highest numbers. This is the population of the United States, the total number of pets, all the geographic names in the world, all the books in the Library of Congress. You add it up, that's 539 million. And that's equivalent to about a 6-word password with 1 letter randomly capitalized. And again, remember the hash hardware we have can do billions of guesses a second. We basically have about half a billion here. If you look at Pareto's principle, look at the answers that account for the vast majority of things, where we're talking about like last names greater than 50 people, or urban areas greater than 2,500, or the more common names, or the more common schools, and so on. You take that list, which will probably get you the vast, maybe, I don't know, pick a number, 60, 70% of the password guesses. You're really down now to only about 404,000. It's worse than that, in that many of these categories, you can order them in terms of probability. So again, this is another census table. This is the surnames, last names, based on how many, in the first column, how many people have the same first name. So there's 11 first names that each have more than 1 million people. And you go down there, and you can see that if you go down even to get to half of the population, you only need something like 3,200 last names. So in terms of, if you're searching for last names in this kind of database, you would start with the most common names and work your way down, and your likelihood of getting a hit, you wouldn't have to get anywhere near halfway through those names. The search order wins first pet names by popularity. You could probably scrape that from Facebook or something. Cities and counties, you might as well order them by population. Books, movies, albums, and stuff like that by unit sales. TV shows by ratings, and so on. So for most of these security answers, unlike passwords, where, yeah, okay, there are some lists of common passwords, but they don't account for most people's passwords. And in fact, nowadays, better systems actually look up the name you want to use for your password, and if it's on one of these frequent lists, they'll just tell you pick something else. Unlike passwords, where there's no natural order to sort, in most of these categories for security question answers, there is a natural order. Okay. So we'll talk about the possible attacks on hashed passwords. First of all, the worst case would be when they just hash the password without any salt. In that case, you can, using these, again, on the theory that you only need to know the answers, you don't really know how they asked you for a last name. All you need to know is that looking at last names, you can do parallel searches or build a rainbow table of pretty much any conceivable answer and store it away and search that in seconds. So hopefully these days nobody is dumb enough not to use salt. But even if you use per user salt, if they have several questions, you can search them all in parallel. And one defense against that, which should be pretty simple, but I'm not sure that anybody does it, is to hash the question along with the answer. Again, that doesn't cost very much. You know what the question is, so you might as well put that in a hash as well, and that at least breaks up that attack. Again, there's the whole question of ordered answers or refined answers. If I know where you were born, I have a lot better ability to guess what your public school was. But even trying every category and every answer is still much faster than password recovery. So the mere fact that security techniques that sort of works for passwords does not in any sense means it will work for security question answers. So let's talk about solutions. First solution is to use one of these resource-intensive hashes or key derivation functions, such as scrypt and argon2. And again, you want to use the salt and include the question and the hash just to break up those attacks. You want to choose parameters on these resource-intensive hashes so that they can't be executed on common GPUs. That's a big win for the attacker if they can. And again, I would suggest you canonicalize answers, get rid of spaces, get rid of capitalization, get rid of punctuations, just to keep the answers as likely to be guessed correctly. So that's one solution, but even if you tune one of these intensive hashes to require 1 minute of CPU per hash, per calculation, which is expensive, if we go back to our most common passwords, 405,000 of them, and an attacker who can get a 10,000 CPU botnet to work on this attack, which is a very modest botnet by what's out there, it would take about 20 minutes on average per hash, so it's still breakable. And again, if you go to a 1 second hash, you replace minutes with seconds, we're talking about 20 seconds per hash. And again, I'm not even taking into account the fact that you can order these searches so that most of them will execute even more quickly. So solution number 2 is to, instead of hashing, to encrypt the answer. And again, this has other advantages. Specifically, somebody at a help desk could look at the answer once it's decrypted and see if it's close enough to the question, even though the hash failed. One thing you need to do is you need to include some random padding in the record that you're encrypting, because otherwise, again, the attacker could encrypt with your public key or whatever key you're using. You could still get some things to trial. But if you put in some random bit, it's sort of like salt, but you don't have to store that with the user's record. It's just junk in that stuff that when it decrypts, you just ignore it. My analogy is if you're allergic to potatoes, if you buy corned beef hash, you have a hard time eating it. But if you get corned beef and fried potatoes, you can just push the potatoes out of the way. So side benefits of encryption is that it encourages more complex answers, because the user doesn't have to worry about the fact that if they get it slightly wrong, it'll be rejected. And you can use humans or even artificial intelligence to verify non-exact matches. But simple encryption has some issues, one of which is the encryption keys can be stolen. Now you can, there are things called hardware security modules that are designed to make it much more difficult to do that, and that's one good solution. But even there, somebody who can get a virus or some piece of malware implanted in the enterprise's computer, that piece of malware can send security question answers to the hardware security module and ask it to decrypt them, even though it doesn't have the keys. But the biggest issue, which is this legal issue, is that the insiders who work in a company still can see the security question answers, because they are accessible on the main computer. Okay, so this brings us to the solution I propose to recommend here, which is to use a asymmetric architecture where, first of all, the answers and whatever random padding is encrypted with a public key. So you have a public key that's stored on the enterprise's computer, but the private key isn't stored there. And when there's a desire to check an answer, a message is formatted to a separate isolated computer where that separate isolated computer has the private key. It can decode the answer. It can also would also be given the submitted answer by the person who's trying to reset the password, and can do the comparison on this isolated computer and send a no-go signal back. And the point is, go or no-go signal back. And the point is that there's no need for this isolated computer to even have access to the user ID, right? Because the user ID can be replaced by some ticket number, some other non-identifying number that is just sent back with this message and is returned with the go, no-go signal. You get some idea of the volume. If you assume this enterprise has 100 million users, each does 2 resets per year, that works out to be 6.4 resets per second on average. There's surge loads because different times of day when people log in. So even at a 10x surge, that's still 64 resets per second. That says that even a modest-sized single server could handle this kind of volume, given the speed of public key encryption and decryption. You probably want more than one for backup, but it's a very modest-sized endeavor. This again. What I'm saying, there's no need to have this research server have any access to the user ID. All this stuff can be done in an isolated setting. Here's a sort of a block diagram. The little red line represents the sort of the enclave where the regular operations of the system are in the upper quadrant there. User logs in. There's a login server. There's a database that has the encrypted answers that were created when the person set up the account. But when they forgot their password, you only send to this the enclave below that red line the encrypted answers and the user's responses, and you get back a go, no-go signal. Another thing you can do is use, I've talked about this in a previous talk, using specialized computers to limit what comes back and forth on this communication channel so that there's no possibility to send messed up messages that embed some sort of an attack or cause a buffer overflow. You make everything fixed format. Okay. So really the big question is, with all these different things, will lawyers like it? And that's something I don't know. The purpose of this talk is to really document why the hashing approach is a bad idea and why this is a reasonable idea that will, in fact, protect the legal concerns they have, as well as providing better security. In the interim, some recommendations for enterprises is, again, encrypt, don't hash. Select questions that will encourage more complex answers. In other words, things like first and last name, not just last name or first name. Street and house number, pet name and breed, and so on. And avoid the simplest answer categories like countries or cities or car models where there's only a few thousand. Recommendations for users, well, for those of you who aren't in a position to influence how your enterprise handles these things, again, I recommend writing down, picking strong passwords and writing them down, using password managers. If you do have to give a security question answer, develop a personal practice to give a more complex answer. If they ask for your teacher's last name, give it first and last name and stuff like that. The other thing is to develop stronger practices for accounts that really matter, like your email, which is the channel through which all these passwords reset techniques come through, banks and so on. Add something special, maybe even create answers, random answers with dice words, and write them down. And of course, use two-factor authentication where it is available. Bottom line, okay, so I hope I made the point. Cryptographic hashing cannot adequately protect security question answers, and we should not allow less than strong security measures just because the legal departments don't understand how this stuff works. Any questions?
What's your opinion of the RSA product?
Sorry.
I haven't looked at it, to tell you the truth. I mean, they have a security question. They have a whole suite for that. Do you know how they stare their answers?
I'm not 100% positive.
I mean, if they hash them, if they don't hash them, The question was, what do I think about the RSA product? And I don't know much about the RSA product, so I'll look into it.
For me, the problem I've noticed with the security questions is twofold. The first one is that I'm married, like a lot of people, and so a joint bank account that's asking what's your first car really is, it depends. Anything that's individual specific on a joint account is already a problem for me and my wife, and I'm sure for anybody who does have a joint account. And so it's, so I'm wondering what the standard's going to say about that. And so, yeah.
Well, if you look at any of these lists of security questions, you find, at least I find a lot, if you weren't married, where your wedding hall was is not an appropriate question, right? Or, if you've never driven a car, that's the first car. So I think one response for that for companies is to provide enough questions that even though some of the questions may be totally inappropriate, others are appropriate. So there's no. And then I think for users, you really have to start thinking about, Years ago when I was taking, standardized tests in school, somebody told me the very useful advice, which was, you're not trying to come up with the right answer to the question. You're trying to come up with the answer to the question that the person who wrote the question was looking for. And they're not always the same thing. So when somebody says, what was your first car, they probably mean you personally, not necessarily you and your wife. Okay, so you have to start thinking that way. But this whole thing is it's bad, okay? And the problem is there's nothing out there that's much better in terms of a solution that doesn't require issuing people special ID cards or putting chips in their wrist, or there's no really good answer out there for something that replaces it. And I agree with you that a lot of these questions are ambiguous and so on. And from a user point of view, your best bet is to come up with some mental rubric for yourself that will provide the same answer each time.
How about inappropriate answers to the questions? What was your first car? Yesterday morning.
Well, I think that's that's a good solution. But the thing is, you need to come up with something, when you're in Costa Rica on your vacation and your wallet gets stolen and you need to get money to pay for the hotel bill and you need to get back in your bank account and, they ask you, what was your first car? And I came up with some really clever answer, but I don't remember what it is. You can trick yourself. So it's like everything else having to do with passwords. If you're really clever about it, you can solve the problem. But man, it's hard to be clever all the time. You want to follow up on that?
Yes, because you could have a consistency. If it's Citibank, it's Citibank yesterday morning. If it's Bank of America, it was Bank of America yesterday morning.
I put that. It's exactly what I have here on that third item there, which is add something special. I agree with you completely, and that's a great solution. How do you get most people to, how do you get your mother and father who's 80 years old to do that? This is what makes all this stuff tricky. Gets back to even making passwords. There are a lot of if you take the first letter of the second word and the third sentence of the book you don't like, or whatever. If you have the self-discipline and consistency to do that, it works. But most of us don't, and our security depends often on people who aren't ourselves who have to make these decisions. So coming up with methods that you can train everybody to do is what's hard, and getting them to do it is what's hard.
So looking at a comparison of storing passwords securely versus storing answers to security questions securely. Password storage is something that's been studied a lot. You covered it very well. Hash salted, strengthened was something that you can get to. Versus your approach.
Let me check your switch there.
Thank you.
Good.
Hopefully everybody could hear me before that. It's a comparison of password storage to security question answer storage. Password storage is already well studied with hash salted, strengthened with something like PPKDF2. It seemed to me like the main advantage that you would have with this approach is that help desk could provide some sort of judicial review of, hey, this answer is close enough, so therefore we'll let you go on. This seems good from a usability perspective. Also, it seems a little bit like a weakness. So I'm wondering why choose this approach rather than what people are suggesting with passwords, which is what I personally do is to use a password manager, and I also store all of my security question answers, which are just created just like a random string of characters, just like I create my passwords and store them in a password manager.
Well, I think that's a great solution. Again, I'm not even. I have maybe there are more people who know more about what's out there in terms of password managers, but the couple I've looked at don't have. It'd be nice if they actually had a security question answer feature to them. That would be really helpful to do exactly what you're saying, and that would be a good solution. But again. To get back to, I a few weeks ago I was I was trying to get into a canoe and I fell in the water and I drown my iPhone, right? And you begin to realize just how much stuff is on your iPhone, right? And that happens, and you also need your password. You know, you had some accident or some mishap, or your stuff got stolen in some foreign country, and you need to reestablish your account so you can get home, or you can pay the bills, or you can get out of jail, right? You know, you may not be able to use your password manager, so it's tricky stuff, you know. And again, if you have the self-discipline, like the gentleman said, to have a really good rubric in your mind that whenever they ask this question, I'm going to tack on my friend Steve's license plate number, you know, something like that. That will get you pretty far. But most of us, you know, don't have that discipline. Any more questions, or we're done? So if you have anybody who wants to catch me out of the hall, I'd be happy to talk about this some more. Thank you all for coming.